Hey guys, this is 8.1, which we are putting into unit 2 because it has to do with linear equations. It's in 8 because it is about systems of linear equations, and systems just means more than one equation. So linear still means line, so these will always be straight. A system means more than one equation. Today it just means 2. So more than one equation, and we are trying to find the solution of the system. So the solution of 2 different equations kind of at the same time. The solution may not exist, okay? And the solution is the intersect or the intersection of the 2 lines. In the system. And I'm just going to call them L1 and L2, okay? So in our first example, we have L1 and L2. Well, in all our examples, we have L1 and L2. They cross. In the second example, they do not cross. And then in this third example, they're actually on top of each other. Okay, so if you L2 is that one. And then L1 is this one. So they cross once, they never cross, they're parallel, and they are on top of each other forever or infinitely, okay? So for this one, there is one solution. And that solution is a point, and that solution has an x value and a y value, right? So the x and the y of that point are the solution, are the solutions for, or is the solution for this equation, and it will also be true for this equation. The solution means that I put, if the equation is 2x equals y, I put that x in here, I put that y in here, and the equation is true. And then we do the other one, which looks like it's a negative. So maybe it's a negative 4x minus 1 equals y. I put that x in here, and I put that same y in here, and it will also be true, okay? And it will be the only point that is true for both of them, always, okay? No other point, no other set of 2 numbers will be true for both L1 and L2. That's scenario 1. Scenario 2 is they are parallel. Parallel lines never intersect each other, so this would be no solution. Because they are parallel. So there will never be an x and a y point that is true for L1 and L2. This is one solution. And the one solution is where they cross, the intersect. All right, and this one, the L1 is graphed, and then L2 is graphed, and it's found on the same line. So every point that makes L1 true will also make L2 true. So this is infinite solutions. Just like the infinity symbol, infinite solutions, because they are on the same line. every point that is true for X will be true for Y. So one point is true for L1 and L2. True for both L1 and L2. No point is true for both L1 and L2. And this one, every point that is true for line 1, I don't know why I keep calling it Y, will also be true for L2. So what we want to do is we want to solve. So those were the graphs. You can solve using the graph, like you look at the graph and where they cross is the solution, or you can solve by elimination method. Solve through elimination. And elimination just means get rid of something, right? So here we want to eliminate one of the variables. We want to eliminate one of the variables because I cannot solve an equation or a system of equation for two variables. If there's an X and a Y and I don't know either X or Y, I can't do anything with that equation, right? But if I only have X, I can get X alone and find out what it is. And then I can put that X in to an XY and I can find Y, right? So how I would eliminate a variable. First, we need to line up the equations. So for example, 3x is right above 2x. They are lined up. Y is right above 3y. They are lined up. And then the constant is right above the constant. So we line up the equations. So here we have 3x and a negative 2x. Now I want them to cancel each other out, right? But the numbers that cancel each other out have to be the same number with opposite signs, right? We would need to find a number. If I wanted to eliminate x, I would need to find a number that both 3 and 2 went into. For 3 and 2, that number would be 6. So I would need to turn the 3 and the 2 into a 6, okay? If I wanted to eliminate the y's, I have a y and a 3y. The smallest number I can turn them both into is a 3, right? So I would multiply everything up here, not just by 3, but by negative 3, so that the y became a negative 3y, okay? So I want to real quick just show you those two different options. When I have a system of equations. Pause. All right, time back. I'm going to give a system of equations and then solve for both x and y. So eliminate, if I want to eliminate x, 2x plus 3y equals 20 will be my L1, and then 7x plus 2y equals 53 will be my L2, okay? So over here, I'm going to eliminate x. Here, I'm going to eliminate y. Two x plus 3y equals 20. 7x plus 2y equals 53. Maybe it's some. All right. So if I want to eliminate x, I have a 2x and a 7x. The common multiple for 2x and 7x, the smallest one I can think of is 14, right? So I want to turn one of these into a positive 14 and one into a negative 14. So here I would just multiply by negative 7. And it doesn't matter if you choose negative or positive 7, as long as one becomes negative and the other is positive. So this time down here, I would multiply by 2. Okay, so negative 7 times 2x is negative 14x minus 3 times 7 is 21y equals 100 negative 140. Okay. Doing 53 times 2 in advance because I don't know. 2 times 7x would be 14x. 2 times 2y is plus 4y. And then this is 106. 53 times 2 is 106. Now I can eliminate the x's. Negative 14 and a positive 14 cancel out. Negative 21 plus 4 is 17y, right? So you're just subtracting, but you're taking the sign of the biggest number. Equals negative 140 plus 106 is 34. Okay, now I need to divide by negative 17. And you get a y is negative 2. Okay, so here I eliminated x and I found y through algebra. Here I'm going to eliminate y. One y is a positive 3, the other y is a positive 2. So we have to use the number 6. To get to 6, I need to multiply by 2, and I'll just make it a negative 2 because 1 needs to be negative. Down here, to get a 6 of 2y, I need to multiply by 3. Okay, so now I have negative 4x minus 6y equals negative 40. 3 times 7 is 21, right? 21x plus 6y equals 53 times 3 is 159. All right, so now I have the negative 6x and the positive 6x, they're gone. 21 minus 4 again is 17. But this time it's a positive. 159 minus 40 is 119, right? Or 109, 119. 119 divided by 17 is 7. All right, so those are just how you would eliminate either one. And it doesn't really matter whether you choose to eliminate x or eliminate y. So here I got y equals negative 2. I can put that y back in the equation, either one, either 2x plus 3y equals 20, or 7x plus 2y equals 53, either one. If I put that negative 2 back in, I can solve for x. So 2x plus negative 6 minus 6 equals 20. 2x equals 26. And I will divide by 2. X is 13. All right, I just wanted to give you an example of eliminating x and eliminating y and how you can do either one with a system, okay? So for this one, I want to eliminate x. x. The x's are 2x and 7x. So the smallest number I can use as a multiple would be 14, right? One of them needs to be a negative 14, one of them needs to be a positive 14. So I'm going to multiply this side, this whole equation, by negative 7. Okay, I'm going to multiply this whole equation by 2. Okay, so what I get is negative 14 x minus 21y equals negative 140 for my first equation. Then I have positive 14x plus 4y equals 106 for my second one. So what happens now is x goes away and I only have y's so that I can solve for y. Negative 21 plus 4, we're just subtracting, but we're using a negative because the bigger number is negative. Negative 17y equals negative 34. I want y alone, so I'm going to divide by negative 17. Y is 2. Okay. Over here, we're going to eliminate y instead of x. So I'm going to multiply everything up here by something and everything down here by something, because 3 and 2 do not, 2 doesn't go into 3, 3 doesn't go into 2. They both go into 6, right? So I want to change 1 to a negative 6 and 1 to a positive 6. I'm going to multiply the top by negative 2, and it does not matter. You could multiply the top by positive 2 and the bottom by negative 3 if you want. And I'm going to multiply the bottom by 3. 3 times negative 2 will be negative 6. 2 times 3 will be positive 6. So negative 2 times 2x is negative 4x minus 6x equals negative 40. 3 times 7x is 21. 3 times 2y is 6. 53 times 3 is 159. Now, oops, sorry, I called that an x, but it's a y. Now we eliminate the y's. Oh, look, it's the same. 21 and a 4. It becomes a 17, but this time it's a positive 17. 159 minus 40 gives you 119. And then I'm divide them by positive 17. So that gives me x is 7. Okay. So that was an example of how to eliminate either one. And then we use this number. We can put it in either equation to find the other. Okay. So if I know y, but I still need x, I can just look at these. Which one looks easier? The top one. So I'll write 2x plus 3y equals 20, and I will substitute the y for a 2 and solve for x. So now we have 2x plus 6 equals 20, subtract 6. 2x equals 14. Divide by 2. X is 7. And you see that you get the same one as you got here. So again, if I put 7 in for x, and this time I'll use the other equation, 7 times 7 plus 2y equals 53. 49 plus 2y equals 53. Take away the 49. 2y is 4. Y is 2. So we still got the same, we still have the same answers. Y is 2. X is 7. So it doesn't matter how you eliminate or which one you eliminate, as long as your math is correct. Okay, that was just wanted to make sure. Make sure we understand what it means to solve through elimination. So we have 3x and negative 2x. That means we need to use a 6. We have a y and a 3y. That one looks better because all I need to do is change that top one to a negative 3y, right? Right now it's just a 1, but I want it to be a negative 3. So I'm going to multiply everything up here by negative 3. Negative 3 times 3 is a negative 9x. Negative 3 times y is a minus 3y equals positive 27. Okay? And then this one gets to stay the same, less work. Negative 2x plus 3y equals 17. These cancel. I just have x, and it's a negative 11x, and this is a positive 44. Divide by a negative 11, and x is negative 4. Okay? So I know there is one solution, and I have the x of that solution. Now I just need to drop that x into either one of those. I'm going to choose the top one. 3 times negative 4 plus y equals negative 9. I chose that one because y is already alone. I don't have to divide. Negative 12 plus y equals negative 9. Add 12. Y is 3, right? Because 12 minus 9 is 3. So my point, remember, it's always a point. Your solution is a point. So the x, y of our point is negative 4, positive 3. Let's do another one. 5x plus 2y equals negative 5. X minus y equals 6. I'm going to multiply this by 2. So now I have 5x plus 2y equals negative 5. And then I have 2x minus 2y equals 12. 5 plus 2 is 7x. 12 minus 5 is 7. X is 1, right? Sorry, that was a joke. I'm going to divide them both by 7. So the point is common, so I can use either equation to substitute x in and find y. I'm going to use that bottom one. It looks easier. So x minus y is 6. 1 minus y is 6. Subtract 1. Minus y, or negative y, is 5. Let's change the sign on both of them. Negative divided by a negative becomes a positive. Positive divided by a negative becomes a negative. Negative 5. So here my point, my x, y point is 1, negative 5. All right, now I'm going to show you how to check it in Desmos. Hold on, let me open Desmos. All right, so we want to mark out the point -4, 3. And then we have the equation. This is the first one. 3x plus y equals -9. Our next point, or our next line is -2x plus 3y equals 17. And they go through the point, -4, 3. So that was the only solution of those 2 points. The other one was 5x plus 2y equals -5. And then x minus y equals 6. Our point that they cross, the point where they cross, excuse me, is 1, -5, which was the point we got. So that's how you would check that your system of equations that you found the correct solution. So for the last 2 examples, the systems each had one solution. The lines crossed in exactly one place. There are special systems where both variables, the variables are x and y, eliminate. So when both variables eliminate, that means there is no x, there is no y, okay? If the remaining equation is true, that means you say there are infinite solutions. It is consistent and dependent, or the lines are right on top of each other. Yeah, that's what that means. If both variables eliminate and it's true, they have infinite solutions, okay? If both variables eliminate and the equation is false, they are parallel, they have no solution, or they are inconsistent, okay? So that would be this guy right next to this guy. No solution, there's nowhere they will ever cross, okay? So let's see if these are special systems. And my math lab might ask you about consistent, dependent, and inconsistent. They just go with those. No solution is inconsistent. Infinite solutions is consistent. All right, I'm going to go down here and rewrite them. 7x plus y equals 4 and 14x plus 2y equals 1. So if I wanted to eliminate, the y's look smaller. So I need to turn this guy into a -2y. So now I have -14x minus 2y equals -8, right? And this one stays the same. 14x minus 2y equals 1. Oh no, I only wanted to eliminate y, but I mistakenly or inadvertently also eliminated the x. Over here we have -8 plus 1, so a -7. But what do we have over here? We have nothing. So this is false. If it is false, it is no solution. All right, let's try the other one. The other one says 4x minus y equals 6 and -12x plus 3y equals -18. I'll multiply, well, here's a positive 3y and a negative y. So I'm going to multiply this by 3. 3 times 4x is 12x, -3y, and 18, right? And then below that, we have negative 12x plus 3y is a negative 18. Those cancel, those cancel, those cancel. 0 is 0. This is true. So this has infinite solutions. Basically, all we did was we reduced this by dividing by 3, right? And we would get that. Well, we'd have to divide by -3, but we would get that. So let's look at each of these in Desmos to make sure. So this first one was no solution. 7x plus y equals 4. And then 14x plus 2y equals 1. So those are parallel. They will never touch. And we said no solution. So that's good. This guy was 4x minus y equals 6 and negative 12x plus 3y equals negative 18. So you see how if I click on the purple, it turns purple. If I click on the black, it turns black. And each of these is a point in common. So every point on the line is a point in common. So that's why that would be infinite solutions, every point on the line, no solutions, the lines never touch. All right. Example 4, solve. Verify using a graphic utility, except, guys, look, it's the same one. I have to do this. Should we do a different one? How about x plus 2y equals 4, and then 3x plus 6y equals 18. Okay, let's see what happens. If I want them to eliminate, I need a -3 up here. So I'll multiply by -3. I get -3x minus 6y equals -12. Okay. And then I still have the 3x plus 6y equals 18. This doesn't look good. So these eliminate. These eliminate. So I have 0 is 6. This is false. So we will say no solution. No solution is possible. All right, the next one. 3x minus 2y is 0. 5x plus 10y is 4. All right, so I could just multiply this one by 5, but I'll do the 3 and the 5. The 3 and the 5, the first number they would have in common is 15. So I will multiply that by 3, and I will multiply this by -5. Running out of space. All right, -5 times 3x is -15x. -5 times -2 is a positive 10y equals 0 times -5 is 0. 5 times 3 is 15. 3 times 10 is 30. And 4 times 3 is 12. We eliminated the x's, good for us. We have a 40y equals 12. So that means y is 12 over 40, we can divide both 12 and 40 by 4 to reduce it, just simplify it, or you can put it into your calculator. 12 divided by 40, fraction, 3/10, because 12 divided by 4 is 3, and 40 divided by 4 is 10, 3/10. So I know y is 3/10, and then I need to put that back up into one of the equations. 5x plus 10y equals 4. I want to choose this one because 10 times 3 over 10 will get rid of my fraction. 5x plus 10 times 3/10 equals 4. 5x plus, so what's happening here is we're multiplying fractions. So 10 over 1 times 3 over 10. And then we go straight across. Or we can just eliminate the 10s, okay? So 5x plus 30 over 10 equals 4. But 30 divided by 10 is the same as 3 over 10, right? Oh, sorry, 3 over 1. 3 over 1 equals 4. 5x plus 3 is 4. Okay, so you can either multiply straight across, or you can look and say the 10s cancel each other out, and it's 3 over 1. Now I'm solving for x. So I subtract 3. 5x is 1. X is 1/5, right? So you need to divide both by 5. So my answer is 1/5 x, 3/10 y. Last one. Ooh, look at this one. So I have, let's just put it down here. I have 4x plus 5y equals -3, and -2y is -8. I can use this one right away. So -2y equals -8. Because there's no x, I can just solve for y. Divide by -2, divide by -2, y is 4. Okay, now I'm going to put it back up here to find x. 4x plus 5y equals -3. 4x plus 5 times 4 is -3. 4x plus 20 is -3. Move the 20. 4x equals -23. Divide by 4. Divide by 4. X is -23/4. And there is not really any way to simplify that. So our point here is -23/4, 4. Okay, so let's quickly check these in Desmos. Our first one is 3x minus 2y is 0, and then 5x plus 10y is 4. 0.2 and 0.3. So what we got was 1/5. If you put 1/5 into your calculator, you get 0.2. And then we got 3 over 10. If you put 3 over 10 into your calculator, you get 0.3. So Desmos will use decimals, and we used fractions. But that is the same point. The last one is 4x plus 5y is -3, and -2y is -8. That point is -5.754. So if you put -23 over 4 into your calculator, you'll get -5.75. And that is the end of that. Thank you for watching, and see you next time.